starts at 9:30, right?
Okay. All right, here's today's attendance. Pass it on. Okay, are there any questions about test 2, which is due tonight? Any questions about test 2? Okay. I do want to say one thing. So a student contacted me, and let's suppose that we had something like this. And this is under this section, is it a well-formed formula or not? And B, then C. Okay. And so suppose that you came across something like this. You might say, well, wait, what's going on here? I have a closing parentheses but no opening parentheses, okay? Well, that's not a case that we hadn't really discussed. So I corrected the test and I either took that off, and this was on 2 problems, or I put an extra parentheses in to make it well-formed or not. Does everybody understand this? If you come across this means you downloaded the test early. Well, of course you're gonna say it's not well-formed because we don't know who the B belongs to. Does everybody understand that? But they're like, hey, did you miss a parentheses? So I just clarified those 2. But if you downloaded it early, you come across something like this, you're gonna say about well-formed formula. If you have, parentheses that open but don't close, or vice versa. Does everybody understand that? Okay. If you've downloaded the test later, then you have the corrected test. So I'll just have to keep my eyes peeled about those questions to make sure I'm grading according to the test that you are working with. Okay. Any other questions concerning chapter 2? Nope. Okay. We will push on, and we'll be getting back on track to be on our timeline according to the syllabus. Okay. So that much is good. Okay. So we're in chapter 3 now, and we're dealing with truth functions. I've been talking about calculating and all of that, and so here's where that comes in. Okay. So we want to know the truth value of a conjunction, when it's true, when it's false, or disjunction, a conditional, biconditional, and a negation, okay? And so these over here, we are assuming on line 1, we are assuming the box is true and the circle is true. If we make that assumption, so we had said something true and something true, we would say it's true, right? And I gave examples last time. For example, if someone said dogs are mammals and cats are mammals, we would say, well, yes, that whole sentence is true. But if someone said dogs are mammals and cats are reptiles, which is false, we would say your sentence with the and is false. Does everybody understand that? Or vice versa, dogs are reptiles and cats are mammals. Well, no, dogs are not reptiles, so this is false. And if we said dogs are reptiles and cats are reptiles, false. Everybody understand that, okay? And then we ask, well, when is a or statement true? And remember, our or is a inclusive or, which means one or the other or what? Both, okay? All right. On this line, also called an interpretation, if I'm being more formal, I'd say interpretation, we're assuming the box is true and the circle is true. And if we say something that's true or true, it's true. So if I say dogs are mammals or cats are mammals, remember our or is inclusive, so we would say that's true because both are mammals. Does everybody understand that? Here we're going to say dogs are mammals or cats are reptiles. Well, the whole thing is true because dogs are mammals, right? So true. Here, dogs are reptiles, cats are mammals. True, because cats are mammals. Dogs are reptiles or cats are reptiles. Neither of those is true, so this is false. On the conditional, the only time it's false is when the antecedent box is antecedent, and the consequent is false. That's when it's false, otherwise it's true. And on the biconditional, I use the example, Fred goes fishing if and only if Barney goes. Let's suppose that that's what it says. Fred went and Barney went, you'd say, yeah, that's true. Fred goes if and only if Barney goes. If I say Fred goes if and only if Barney goes, and Fred went but Barney didn't, you'd say, that's not true, because Fred went without Barney. And if Barney went without Fred, you'd say, that's not true. They don't always go together. And then, of course, if neither of them went, you'd say, well, that's true. They only go fishing together. So Fred didn't go, so neither did Barney. Okay? And, of course, if the box is true, a not box is false. And vice versa, if box is false, not box is true. Does everybody understand? Okay. So now we're going to start using this. Did we start doing some problems from 3.1 last time? Or did we only get this up on the board?
I think we all have that.
Okay, all right. So I'm looking at homework 3.1. And by the way, I don't know if you've noticed, but right before all the homework in the back, there's always a page or two that pretty much summarizes everything in the chapter, right? So you have this little handy crib sheet, and this truth table that I just wrote up here is on that page, right? So you can just pull that out or print it out, and use that as a little handy dandy guide, okay? The only difference is I did the negation first. Okay, so I'm working on homework 3.1. And what we have to do on 3.1 is we have to calculate the truth value of a complex statement given truth values for its parts, okay? And on these problems on 3.1, A, B, and C, those are all going to be true, okay? Wherever you see an A, it's true, B, true, C is true. I'm going to use lowercase to signify that this is the truth value as opposed to a statement constant, okay? X, Y, and Z, those are all false. Wherever you see those, you're saying it's false, okay? So let me do problem number 1. So first thing I'm going to do is write down the complex statement that we're trying to figure out the truth value. Not Z, if and only if X, then not B. Okay, so there's our expression. The first step is to substitute in the truth values, the assigned truth values. Okay, Z we're told is false, so I have not false. If and only if X is false, then not and B is true, okay? Now, generally speaking, you work from inside the brackets out, right? Of course, you eliminate any negations that you can, okay? Always first. This negation we can get rid of because it only applies to the F. So not false would be what? True. And so now I'm just going to rewrite everything else, false, then, and not true would be false, okay? So I calculated those parts. So now the next thing I should calculate is this, false, then false. So this is where I'm getting those answers from. False and false, so both parts are false. So I look for a case where both are false, right here, line 4. And then I go over to the conditional. We're dealing with a conditional, right? So I go over here to the conditional and I discover when both parts of a conditional are false, the conditional is true. And then I write that result down below the operator so I know this is the value for the conditional. And then I'll rewrite everything else. So now I have true if and only if true. Well, what's the answer to that? So both of them are true, so I go over here and I say, oh, this is a case where both of them are true, I'm dealing with a biconditional, so I come over here and I see, oh, hey, when both parts of the biconditional are true, the biconditional is true, and so the final answer is true. Does everybody understand that? Okay, so let me do another one. And if you have questions, ask. The most important thing is you understand where I'm getting these answers from, okay? So let me do 3. So this is number 3. Okay, I have X and A or Y and Z, okay? First step is to put in the truth values, the assigned truth values, and we're using these values on all these problems. So X is false and A is true, or Y is false and Z is false. Okay. So I need to work from the innermost brackets out, which means I need to do this calculation first, false and false. So I look for a case where both statement constants are false. That's line 4, right? And I go over to the conjunction, and I see that in the case where both conjuncts are false, the conjunction is false. And I write the result under the operator so I know this is the result of that. And then I'm going to rewrite the rest of the problem. Okay? So now, working from the innermost brackets, I have to calculate this, true or false. So the first one is true, the second one is false. Let me go look and find that case. First one true, second one false. That's line true. First is true, second is false. And the operator I'm dealing with is or. So I go over to the or and I see, in this case, where the first is true and the second is false, the or is true. So that's where this comes from. I say, so this is true. The result of that is true. So now I end up with false and true. So look for a case over here.